Hey everyone, this is Rowan Shaw with DiagKNOWstics Learning, here with some math, and my cameraman is asleep. First, let's talk about inequalities. That's when you have, kind of looks like an equation, except it's not equal. It's sort of less than or greater than, or greater than or equal to, something like that. So how do you deal with that? Basically, the trick is treat it like it's an equal sign. So here, what would you do first? To solve for x, imagine if this were an equal, you'd subtract 3 from both sides. So -8 minus 3 is -11, I guess. And that's just 5x, and then just divide by 5. So this would be -11/5. That's less than x. And that's it. Well, it's not quite that simple, because here we were lucky, but if you ever have to divide or multiply by a negative number, that's when you just have to flip the sign. That's really the only difference. For example, let's say we have this and we want to solve for y. Well, first we'd subtract 4x from both sides, so we get -2y less than, and then we subtracted it, right? So -4x, we get that plus 10 over there. Now we can divide by 2, but not just 2, -2. So then because we divided by a negative, so notice you can add or subtract, negative, positive, doesn't matter, doesn't affect that sign. But if you divide or multiply by a negative, you flip the sign. So here, because we're going to divide by -2, this less than now becomes a greater than. And dividing by -2, this -4x would become a positive 2x, and this dividing this by -2 makes it -5. So there's that. What if you were asked to graph this? Well, basically, just like you'd graph an equation, imagine this at equals, then this is just an equation, mx plus b, right? The slope is 2, so it's sloping up, and the intercept's -5, so really just -5 sloping up. There's the graph, except it's not equals, so it's not really this line. This is sort of like a dotted line, but instead it's greater. So really the y values aren't really equal to this line, but they're always above this line. So really it's actually, you shade it over here. So this is basically how you graph an inequality. Now let's talk about absolute value. Absolute value is really just taking the positive version of that number. If the number's already positive, just keep it like that. So the absolute value of 8 is 8. The absolute value of -8 is also 8. What if you're given this equation over here and you want to solve for x over here? What do? Your instinct might be, let me just ignore the absolute value. And believe it or not, that's actually one of the things you're going to do. So basically, long story short, whenever you're given an absolute value and you want to solve for it, basically there's two possibilities here. This thing on the inside, x minus 3, it might just equal 8. So really, one thing is just ignore the absolute value. The other thing that might be the case is this thing on the inside might actually equal -8. Because if this x minus 3 really is equal to -8, not just 8, well, guess what? When you take its absolute value, that'd still be 8, right? So really, long story short, the way to solve an absolute value is you basically write one case where you ignore it, and another case where you basically get rid of the absolute value, but set it equal to the negative version of whatever it's equal to. So now going ahead and solving this, here we just add 3 to both sides. So here x is either 11 or x is equal to -8. Plus 3 would be -5. And again, you can kind of check your answer. Here, if x is 11, will this work? What's 11 minus 3? 8, absolute value. That works. And what about -5? -5 minus another 3 is -8, but when you take its absolute value, you get 8. So that works too. To graph an absolute value, it kind of just looks like a V. So over here, if the question is just, what's the graph of absolute value of x look like, it really just kind of looks like that. And the usual rules of transforming functions apply. So here, what would this look like? It looks like that V, except a -3 on the inside means it's shifted 3 units, not to the left, but to the right, because it's opposite day on the inside. So really, this is over 3. And then on the outside, it's just normal, so that's 4 units up. So really, it's kind of like the vertex is 3, 4, but really, it's still a V. And finally, let's just close with an example that sort of combines inequalities and absolute values. So let's see. Again, because it's an absolute value, we know that there's going to be kind of two different solutions here. One is just ignoring the absolute value, so we could have -3x plus 5 is simply greater than or equal to 19. That's one solution. The other is that same thing, -3x plus 5. Now the opposite, so 19, -19. But see, with this, whenever you combine them, and you don't just set it equal to the negative version, but you actually have to flip the sign also. So it's, instead of greater than, it's less than or equal to -19. So again, just to recap, whenever you have both, just still set it equal to both the 19 and the -19, but for the negative version, also flip the inequality. So when we solve it, we just get here, subtract 5 from both sides, so -3x is greater than or equal to 14, and then divide by negative 3. So because we're dividing by a negative, we flip the sign, so it'll be less than or equal to, and it's negative, whatever 14 thirds is, so that. And then also here, same thing, we subtract 5 first, so negative 3x. Now less than or equal to, when you subtract the 5, you get negative 24. And then finally, you divide by negative 3. Because we're dividing by a negative, we flip the sign. That's not going to be greater than or equal to. Here the negatives will actually, negative over negative is positive, so it's just 24 over 3, which is A. So these are your solutions. If that helped, make sure to sign up on DiagKNOWstics.com to learn some more math and learn to know.